Hello class, in this video I'll be introducing vertical asymptotes and how to sketch a rational function near a vertical asymptote. Let's begin. The line x is equal to a is called a vertical asymptote of the graph of a function f if f approaches infinity as x approaches a from the right or a from the left, or f approaches negative infinity as x approaches a from the right or x approaches a from the left. So what do we mean by x approaches a from the right and x approaches a from the left? X approaches a from the right means we are only looking at values of x that are greater than a. X approaching a from the left means we are only looking at values of x that are less than a. And we want to make a note here, the graph of a function will never cross a vertical asymptote. All right, so let's take a look at an example. Find the vertical asymptote of the function w of x is equal to x squared plus 4x plus 3, all divided by x plus 2. Then sketch the graph near the asymptote. So the first thing we're going to want to do is we're going to want to completely factor w of x if possible. So the numerator factors as x plus 3, x plus 1. Since there are no common factors in the numerator and the denominator, we say that w of x is in lowest terms. So now that we know that w of x is in lowest terms, what we're going to do is we're going to find the values of x that x cannot equal. So if x plus 2 is equal to 0, w of x is undefined. So this implies that x is equal to negative 2 is not in the domain of w of x. And since w of x is in lowest terms, x is equal to negative 2 is the equation of the vertical asymptote. Okay, so now let's sketch the graph near the vertical asymptote. I'll start by placing a dashed vertical line through x is equal to negative 2. I'm making the line dashed because this vertical line is not part of the graph of w of x. So now what I would like to do is test a couple of values of x that are next to the vertical asymptote. So the first value of x that I'm going to test is going to be less than negative 2. So I'm going to test negative 2.1. So this is going to equal negative 2.1 plus 3 times negative 2.1 plus 1, all divided by negative 2.1 plus 2. Now I do not care about the actual value of w of x when x is equal to negative 2.1. I just want to know the sign of the answer. So we know that negative 2.1 plus 3 is going to give a positive value. We know that negative 2.1 plus 1 will give a negative value. Then we're going to divide, and we have negative 2.1 plus 2. That will also give a negative value. So a positive times a negative is a negative, but a negative divided by a negative is a positive. So what this means is that as x approaches negative 2 from the left, w of x is going to approach positive infinity. Now I'm going to test a value of x as x approaches negative 2 from the right. So this time I want to find a value of x that's greater than negative 2, and I'm going to go with negative 1.9. So this will equal negative 1.9 plus 3 times negative 1.9 plus 1, all divided by negative 1.9 plus 2. So the sum of the first factor is going to be positive. The sum of the second factor is going to be negative. And the sum of the factor in the denominator is going to be positive. So w of negative 1.9 is going to be negative. So what this implies is that as x approaches negative 2 from the right, w of x approaches negative infinity. Okay, going back to the graph. Recall that the vertical line is x is equal to negative 2. The section to the left of the vertical line is negative 2 from the left, and the section to the right of the vertical line is negative 2 from the right. And from our test values, the graph approaches a positive infinity as x approaches negative 2 from the left, and the graph approaches negative infinity as x approaches negative 2 from the right. And we are done.